Ensoftec has developed a series of videos for the selection and design of stormwater facilities for land disturbance projects. In this video, I shall show you the design of extended detention ponds or ED ponds using SWMSOFTVA. Virginia Department of Conservation and Recreation, or DCR specification number 15 gives a complete description of these facilities, their performance, and criteria for design, their feasibility and design applications, regional and special case design adaptations, their construction and maintenance and community and environmental concerns for ED ponds. The pictures and tables shown here are from these specifications. Figure 15.1 gives the schematic of a typical ED pond. This includes 4 bay, aquatic benches, micropools as part of the pond. ED ponds, like wet ponds and constructed wetlands, are the final elements in the roof-to-stream runoff reduction sequence. Therefore, they should be considered only if there is remaining treatment volume or channel, and/or flood protection volume to manage after all other upstream runoff reduction practices have been considered and properly credited. The designer may also consider providing hybrid systems, where portions of the runoff are diverted to bioretention, filtration, or other sand filters while the ponding depth is provided for quantity control. Table 15.1 gives a summary of stormwater functions provided by ED ponds. Table 15.2 gives the extended detention pond criteria. The designer can select the baseline design, Level 1, or an enhanced design, Level 2, to maximize the pollutant load removal and runoff reduction. You will notice that for Level 1 design, the average detention time is 24 hours, while for Level 2 design, the average detention time is 36 hours. The sizing of the outflow orifice should be adjusted accordingly. In addition to pre-treatment for bays and micropools, the enhanced designs call for additional cells or features, like deep pools and wetlands. The total volume of all 4 bays should be at least 15% of the total treatment volume. The total area draining to the Level 1 ED ponds is generally less than 10 acres, while that for Level 2 ED ponds is greater than 10 acres. While developing the footprint of the ED ponds, the civil and landscape designers shall ensure compliance of all internal design features as specified in the DCR manuals. SWMSOFTVA deals with the hydraulic design aspects of these BMPs. I now open the project which we had set up in video 3. BMP 3 of Outfall 1 is an ED pond. I shall use this example to demonstrate the design steps. I go to File, Design BMP Facility. This opens the Extended Detention Basin screen. You will note that the contributing drainage area, or the site area, and the treatment volume are already populated in the screen. It is common for ED ponds to be used as temporary sediment basins during the construction phase of the project. While the pond grading is done at this stage, the outflow structures, like the risers, spillways, and orifices, are made as temporary structures for sediment control during construction. You will notice that there is a radio button at the top. Is the facility used as a sediment basin? If I click on No, the program will not calculate the required clean-out, wet, and dry storage volumes based on DCR's erosion and sediment control manual. These are: required wet storage volume equals 67 cubic yards per acre of site area. Required dry storage volume equals 67 cubic yards per acre of site area. Required cleanout volume equals 50% of the required wet storage volume. If I click Yes to the top radio button, you will notice that these values are calculated and shown. The storage summary table at the bottom gives the required volumes, their corresponding pond elevations, the provided elevations, and the corresponding pond volumes. I have not yet entered the pond elevations and corresponding storages. This is my next step. I click on Compute Volume. This opens the Basin Volume Computations worksheet. This sheet has 6 columns and 12 rows. I need to fill the first 2 columns only. These are elevation in feet starting from the lowest bed elevation and surface area, at that elevation in square feet. I start filling this data from the first row. I make sure that the elevations keep increasing as I move down each row. Also, as this is a pond, the areas should also increase as the elevation increases. An error message is displayed if the data is incorrect. While there are 12 rows to accommodate up to 11 feet of storage depth, assuming that the incremental elevation is 1 foot, it is not necessary to fill in all the rows. It is prudent to fill in areas and elevations up to the top of embankment. Also, make sure that the areas include all 4 bay and micro pool areas. Having entered all the pond elevations and areas, I click the Compute button at the bottom. This will compute and populate all the remaining fields. Column 3 gives the average area in square feet between successive elevations. Column 4 gives the volume in cubic feet between successive elevations. Columns 5 and 6 give the cumulative volumes from the lowest bed elevation to final elevation in cubic feet and in acre feet respectively. I could always click on Clear button at the bottom, which will clear all the 6 columns. This will enable me to re-enter the first 2 columns and recompute basin volumes. Exit will close the screen and puts me back to the previous screen. You will notice that the elevation required for the treatment volume is calculated and entered here. I can provide my own elevation, which would be the top of spillway elevation. I now click on Compute Storage button at the bottom. This will compute the storage volume for the proposed elevation. If I had clicked on the radio button yes at the top, the program will give the required wet, dry, and clean out elevations. If I give the proposed elevations for these volumes and click on the Compute Storage button at the bottom, the program will compute the volumes for each of these elevations. Please note that these are required only during the construction stage and are not part of the final design. I go to the top menu bar and click on File, Save. This will save all the data including pond elevations and areas. To print the results, I go to the top menu bar and click on File, Print. The print report, which is in Excel format, gives the results including a stage storage curve. The next step is to perform the outlet analysis. I go to the top menu bar and click on File, Outlet Analysis. This opens the outlet analysis screen. You will notice that there are 2 sections here. To the left, you will notice orifice details, spillway details, and emergency spillway details. To the right, you will notice that the water quality volume required is already populated. I can select 24 hours or 36 hours from the pull-down list for extended detention storage time. I enter the maximum hydraulic head. There are 2 procedures to determine the orifice size to hold the extended detention storage volume. The program uses the DCR method to average hydraulic head, which is the preferred method is given in the Virginia Stormwater Management Handbook, and gives the size of orifice in inches. This size is used in the orifice sizing to the left of this form. There are 3 types of orifices for the user to choose from. 2 circular shapes and 1 rectangular shape are given. The center line elevation of an orifice should be such that the invert of the orifice should be above the lowest bed elevation. The checkbox is provided against each for the user to select. Likewise, there are 3 types of spillways for the user to choose from. A side open riser, a circular riser, and the rectangular standard SWM1 riser are available. There are 2 types of emergency spillways for the user to choose from. A broad-crested weir and weir wall types are available. The checkbox is provided against each of the above for the user to select. I enter the data applicable for the proposed riser structure. I then go to the top menu bar and click on File, Save. This will save all the above data. Next, I go to the top menu bar and click on File, Print. The print report, which is in Excel format, gives the results including a stage discharge curve for the outflow from the AD pond. In order to determine the adequacy of the AD pond, to hold the water quality volume, and to safely convey the 10-year and 100-year design storms, it is necessary to route the inflow hydrographs across the pond, with due consideration to pond storage and the outflow rates. This is done using the storage indication method routing procedure as given in section 11561 of the Drainage Manual. For the inflow hydrograph, the program uses the NRCS dimensionless unit hydrograph. In an event-based model such as the NRCS method, the rainfall hyetograph for the design rainfall event is based on the CN method, and the application of the NRCS 24-hour rainfall distribution is well documented. Now that I have the inflow hydrograph, the stage discharge curve, and the stage storage curve, I go to the top menu bar and click on File, Generate Hydrographs. This will produce an Excel spreadsheet which provides recursive computations for the storage indication routing. Inflow and outflow hydrographs are generated for the 2-year, 10-year, and 100-year design storm events. For retrofit BMPs with pre-development site areas and inflows, the hydrographs for existing conditions are also generated. If I go to File, Summary Table, a new screen opens giving the drainage areas, pre- and post-rainfall depths, peak discharges, and the corresponding water surface elevations inside the pond for the 2-year, 10-year, and 100-year design storm events. The final step in the design of ED ponds is to perform outlet analysis. I go to File, Perform Outlet Analysis. This opens the Outlet Analysis worksheet. You will notice Outlet Barrel Sizing worksheet to the left and Emergency Spillway Design to the right. The 10-year and the 100-year peak discharges are already populated in the form. I enter the outflow barrel details, its length, diameter, invert in, invert out, and the barrel material type. I also enter the top of riser elevation. When I click on Compute, the program calculates the hydraulic head at the riser. The remarks field indicates if the water surface elevation in the riser is inside the riser, or above the riser, indicating inlet control or outlet control. The barrel size, slope, or material can be adjusted to ensure that the water surface elevation is inside the riser. Now I enter the emergency spillway details, its length, width, and the emergency spillway top elevation. I also enter the top of embankment, and the required freeboard. When I click on Compute, the program calculates the head, above the weir. The remarks field indicates if the freeboard is adequate or not. I go to the top menu bar and click on File, Print. The print report, which is in Excel format, gives the results of outlet analysis. This concludes the design of extended detention ponds using SWMSOFTVA.